This question is given in GATE 2003. They are saying this. Let S be the stack of size n greater than or equal to 1, which means there is a stack. Okay, and then starting with the empty stack. So initially there is nothing in this stack. Suppose we push first n natural numbers, which means into this stack we are pushing all the natural numbers in sequence. What do I mean by in sequence is 1, 2, 3, 4, 5, 6, so on n. That is a sequence. And then perform n pop operations. So after pushing all the elements into the stack, I am going to perform n pop operations. I'll perform n push and then n pop. Okay. Assume that push and pop operations take x seconds each, which means whenever you try to push an operation, push an operator or pop it, I mean push a number or pop a number, the time taken for push or pop is x seconds. That is what they are saying. And y seconds elapse between the end of one such stack operation and the start of the next operation. So they are saying that between any two operations, either it could be push and pop, or it could be two pushes, or it could be two pops, whatever it is, between every two operations there is a time gap of y seconds. Okay, and now one such, okay, yes, and yeah, for n m greater than or equal to 1, define the stack lifetime of m, which means for every element there is something called as lifetime. So they are saying that lifetime is time elapsed from the end of push to the start of the pop operation, which means the amount of time a element is going to, a lifetime of an element is the amount of time that is elapsed between after pushing the element and before popping the element. So after pushing the element you start the timer and see when it is going to be popped off. That entire time is called lifetime of an element, right? And now they are asking the average lifetime of an element of this stack is, which means on average how much time is each element going to spend in the stack. See, what they mean to say is like this. They are saying that there is a stack, right? And they are saying that we are going to push elements into this stack, first 10 natural numbers into this stack, one after the other in this sequence, which means 1, 2, 3, 4, 5, 6, so on n. That is what they are saying. Okay, and they are saying that in order to push an element or to pop an element, the time taken is x seconds. Okay, and between two operations, either between two pushes or between two pops or between a push and pop, whatever it is, between two operations the time elapsed is y seconds, which means we are not going to do immediately two pops, we'll wait for some time. Then they are asking what is the average lifetime. Average lifetime is, for example, lifetime of 1 will be after pushing 1, how much time does it take to push all these elements and pop all of them. That is called lifetime of 1. Then only 1 will be popped off, right? And what about 2? Lifetime of 2 will be after 2 is pushed in, how much time does it take to push all these elements and then to pop all these elements, then only 2 will be popped off, right? That is the lifetime of 2. Likewise, you are supposed to find out the lifetime of all the n elements, right? And then you are supposed to find what is the time taken to average lifetime, which means add them all, lifetime of each element, add them all and divide it with n. Okay, now we shall see how to solve it. Let's take small numbers. Let us say I want to push only one element, right? Then let me see what is the lifetime of that element. So if I want to push 1, right, then after pushing 1 and before deleting 1, how much time, if there is only one element, I'll push and I'll pop immediately. Then what about the lifetime of 1? After pushing 1 and before popping 1, how much time is elapsed? Only some time between two operations. So they already said that before any two operations, between a push and a pop, the time elapsed is y seconds. Therefore 1 will be there inside the stack only for y seconds. See, try to understand it carefully. It is very simple. What I mean to say is, you are trying to push one element into the stack. How long is it going to remain in the stack? Until you pull it out, right? Now after pushing it and before pulling it out, which means before popping, how much time will be there? It will be y seconds, because they said that between any two operations time elapsed is y seconds, right? So if there is only one element, then the time is y. Got it? Now if there are two elements, let us say I want to push two elements and then I want to pop them off, and I want to see what is the average lifetime. So let us say I want to push one element and then push the second element. Okay, now I want to see what is the time elapsed. So for the lifetime of 2, I'll push it and then immediately I pop it. So how long is y2 going to be there in this stack? It is going to be there exactly for y seconds. So lifetime of the top element is always y seconds. And what about the lifetime of the first element number 1? After pushing 1, I have to push 2, isn't it? So how much time is going to take for one pushing? X, isn't it? Plus, isn't it, after pushing okay, let's go step by step. Okay, watch it. After pushing 1, before pushing 2, I have to wait for some time, isn't it? How much time? Y time. Plus, after waiting that time, I'm going to push 2. How much time is taken to push an element? X time. And after pushing 2, I have to wait for some time. Right? Why? Because I cannot immediately pop it off, right? So how much time? Y time, right? Plus, then I can pop it off. So how much time is required to pop it off? X time. Plus, again I have to wait for some time before popping it off. So how much time I have to wait? Y time, right? So how much is it? It is going to be 2x plus 2y plus y. So why did I write like this is, just observe this. Now after pushing 1, I have to push this element once and pop this element once. So for pushing and popping this one element, time taken is 2x, isn't it? And then if we have one line here, this one line says that before pushing this you have to wait. See, after pushing 1 you have to wait for this long, and then after after popping it we have to wait one time, that is why 2y. Are you observing it? This line is responsible for 2y. How? The reason is, after pushing 1 I have to wait for one time, and then after pushing 2 I have to wait for one time before popping it, isn't it? See, after pushing 1 I have to wait for one y before pushing y, and after popping y I have to wait for one y before popping y. That is why this line is responsible for 2y. Got it? And what about this one? So this is exactly once. The reason is, after pushing 2 I have to wait for only one y before popping it off. That is why 1y. Got it? So the total time taken in case of two elements, the total lifetime of each element is, in case of two elements, is how much? 2x plus 2y plus y plus y. This is the lifetime of element number 1, and this is the lifetime of element number 2. Now they are asking about the average. The average means you are divided with 2, because these are the two lifetimes, isn't it? So two elements, therefore you divide with 2. Then how much do you get? I think you are going to get 2x x plus 2y, isn't it? X plus 2y. Now let's do the same kind of analysis for three elements. See, why am I trying to do this 1 2 3 elements is because once you do such a kind of analysis, you can substitute the answer in the n in terms of, in place of n, you can put the options in the option, in the values of n in the options, and you can eliminate the options. That is one way to do it. Other way is directly deriving the answer. We shall do it, but then once we work with the small numbers, we'll understand exactly what is happening there. In exam, whenever options are given in terms of n, you try to take n equal to 1, n equal to 2, n equal to 3. So with these three numbers, you can eliminate the options and you can pick the answer directly. Method is going to be long, but this is a shortcut. I'll even tell you the method also. Okay. So now let us say we are working on three elements. Okay, which means I'll push element number 1, and then I'll push element number 2, and then I'll push element number 3. Now I want to find out what is the lifetime of each element, and then I want to find out the average lifetime, right? So what is the lifetime of element number 3? It will be pushed, and then we'll wait for y units, and then it will be popped. Therefore the lifetime of element number 3 is y seconds. What about the lifetime of element number 2? After pushing this one element number 2, I have to push 3 as well as pop 3. Therefore time taken is 2x. Time taken is 2x to push 3 and pop 3, plus there is a line here. What does this line indicate? After pushing 2, I have to wait for y time before pushing 3, and after popping 3, I have to wait for y time before popping this, right? Therefore, this line will contribute to 2 into y. Every element will contribute to 2 into x, and every line will contribute to 2 into y, plus the top line, this one will just contribute y, isn't it? Therefore, the lifetime of 2 is equal to 2 into x plus 2 into y plus y, right? What about this one? Lifetime of this one, how many elements are above it? 2 elements, right? So these 2 elements have to be pushed as well as popped, isn't it? So 2 elements have to be pushed 2 times and popped 2 times, therefore it is going to be 4x. Are you understanding it? The reason is these 2 elements will be pushed once, so x plus x is 2x, and these 2 elements will be popped once, x plus x is 2x. Therefore, for pushing and popping, time taken is 4x. And now there are 2 lines. You remember, you forget about the top line because that is just going to contribute 1 by. These 2 lines are going to contribute. See, one gap will be there before pushing, right, and one gap will be there before popping. Therefore, every line is going to contribute 2y. How many lines are there? 2 lines, and every line is going to contribute 2y. Therefore, these 2 lines are going to contribute 4y time, plus this line is going to contribute only 1y. Got it? Right? What is the total time? You can add this all up and then divide with 3, right? And using this, you can, I didn't write the options here, but then you can check the options, you can substitute it, you'll definitely get the answer, right? Like this. Now, what is the actual procedure to solve it is this way. Watch it. The actual procedure to solve it is, let us say there are n elements, right? Then what happens is, if you observe it, for the top element, the time taken will be this much, the lifetime, and for the element next to it, the time taken will be this one, right? So if you are coming down, see this, if you have n elements, right, then if you have n elements, then how many elements will be above the last nth element? N minus 1 elements will be there, right? So what happens is, in case there are 3 elements, I am talking about if there are n elements, right, then 1 will come down and n will be here. So above 1 there will be n minus 1 elements, right? Therefore, how many push and pop are required? 2 into n minus 1 push and pop are required, isn't it? Therefore, 2 into n minus 1 x time is required for push and pop. Are you following it? See, if there are n elements, then 1 will be here and n minus 1 elements will be above it. How did they come there? By pushing. Therefore, n minus 1 pushes and I have to go out. Therefore, n minus 1 pops, right? That is by 2 into n minus 1, because n minus 1 pushes and n minus 1 pops. And for each operation, time taken is x units, right? And then every line is going to contribute, to a time of 2y. So how many lines will be there? N minus 1 lines will be there if you count it, isn't it? See, above 1, how many lines are there? Actually 3 lines are there, but then we are only counting 2. So in case of 3 elements, above 1, there are 3 lines. So leave the first line, then how many lines are there? 2. Similarly, if there are n elements, above 1, how many will be there? N lines will be there. Leave out the first one, then how many remaining lines will be there? N minus 1. Therefore, 2 into n minus 1 into y. The reason is there are n minus 1 lines and each one will contribute 2y time, right? Plus the last one will contribute y. So this everything has to be added. So if you observe it, it is, you can write it like this, 0 into x plus 0 into y plus y, right? So if you observe all this, right, so for the first element it is the case, for the second element it is the case, for the third element it is the case, for the last element it is the case, right? So how can you write this all is, how many y's are there? Exactly n y's are there. So this entire factor, all this are going to be exactly n y's, isn't it? Plus how many these second elements are there? So you can write this all like this, sigma I equal to 1 to n minus 1, right, I into, right, because I'm pulling out this, right, it is 0, 2, 4, 8, so on, 2 into n minus 1 into y into 2, right, because Are you understanding it? Because it is 0, 2, 4, 6, so on to n minus 1. That is why it is sum of all even numbers till 2n minus 1. I am pulling out 2 as common. Then what comes out? 2 into sigma I equal to 1 to n minus 1 I into y plus this term. This term can also be written like this: 2 into sigma I equal to 1 to n minus 1 I into x. Got it? So we can write like this, and now we can expand it and we can find out the answer. Now watch this. So this factor, so what is this? Sigma I equal to 1 to n minus 1 I. So that is nothing but the sum of first n minus 1 natural numbers, isn't it? Sigma I equal to 1 to n minus 1 I. N minus 1, sum of first n minus 1 natural numbers, right? Sigma I equal to 1 to n minus 1 I. So now what is sum of first n minus 1 natural numbers? N minus 1 into n divided by 2. How did I get this? Sum of first natural numbers is n into n plus 1 by 2, and in place of n I am substituting n minus 1. Then it is n minus 1 into n by 2, right? So these two will cancel out and x will remain. Plus again the same thing here. What is it? 2 into n minus 1 into n by 2. So these two will get cancelled and y will remain there, plus ny, right? Now after finding it out, you are supposed to find out what is the average. Average means you have to divide this with n. So if I divide it with n, then the answer is going to be n minus 1 into x plus n minus 1 into y plus ny, right? And maybe if you try to solve it, it is going to be n minus 1 into x plus y plus ny, right? Okay, so option is somewhere here. So option is something like this. I think they have pulled out something like nx or something. I think they have written it like this: n into, I have to check it, n into x plus y minus x plus y plus n into y, something like this is written. Okay, anyway you can see that you can rearrange this and get the option. Okay, I didn't write the options here. So one way to do it is you take n equal to 1, 2, 3 and substitute in the options, get it. And other way to do it is you can follow this procedure and you can get it. Okay, fine. Now, I missed out one thing here. See, this one has to be divided, right? When we are dividing ny with n, then we are going to get y only, right? Then what we get? We are going to get y. Then we get only y. Then minus y and plus y will get cancelled out. Therefore, the answer is n into x plus y minus x. This is the answer. This is given as the option. Okay, fine.